Hi, I'm Sarah. I'm not so good with technology, as it turns out. I am a senior research engineer at Mozilla, and I work on the systems research group. And so a lot of folks here today work on the security engineering team. My team is a small band of researchers that are trying to develop new techniques and novel data products. We have another member of our team in the back right there, Alana. And so today I'm going to talk to you a little bit about the work I've been doing on automating methods for fingerprinting detection. And I'll start with the current techniques, and this is starting where Steve left off, and really a lot of the work that I do builds on his work and work of other researchers like Anupam Das, who is here in the audience too. So we'll look at what we're currently doing, the methods that I have in development, and all of the opportunities and questions that these methods have brought up that I hope some of you are interested in collaborating with me on. And so if I'm going to squish Steve's presentation this morning down into a slide, so if you can just take yourself back in time to when Steve was talking about device properties and fingerprinting and the short bit that he gave on the current process that we use. And so to summarize that again, we start by doing a crawl using OpenWPM, which was a tool he and other colleagues at Princeton developed, and we now continue to maintain at Mozilla. OpenWPM is an instrumented version of Firefox that allows you to go and browse websites, crawl websites, and then collect a bunch of things. The HTTP requests, the redirects, the resources that were loaded, all of the headers, and of particular interest to me, all of the JavaScript or the instrumented JavaScript APIs that were hit, and a bunch of data about that. And at the moment, we typically do crawls on the Alexa top 1 million homepages, but my team's also done some different sort of size and profile of crawl, which has yielded some interesting things. Then we move into the analyze section, and we apply a series of heuristics to document if a script that was loaded is either doing canvas fingerprinting, font fingerprinting, audio, or WebRTC. And then in the validation step, those scripts that are flagged and present on over 10 domains are then sent off to disconnect for validation, and as Steve described, checked rigorously to sort of determine their status. And so to dig into this a little bit more, I'm just curious, how many people here have used or heard of OpenWPM? Awesome. Well, I will keep this short. So the OpenWPM visits a page, records the resources that were loaded, and then for the instrumented JavaScript APIs, so those are the ones that I've highlighted here in bold, we collect information about the calls that were made. So you end up with a table where you've got the API, you've got the arguments that passed, the values it returned, a bunch of other metadata. And then in the heuristics approach, which Steve is widely published on, you apply a rule set to that table and to try and determine whether a script is fingerprinting or not. And so I'll just go through one, which is the canvas fingerprinting technique. And so there are sort of 4 basic steps. First, is the canvas large enough? Because it needs to be large enough so that when you turn it into an identifier, that you have sufficient entropy to isolate this particular user or this particular browser. Again, is the text written to the canvas big enough to generate that entropy? Then has the calls that would actually exfiltrate information and turn it into an identifier been called? And then the last step is actually a sort of a negative signal, which is have save, restore, or add event lister been called? Because if they have, this is likely going to be a valid use of the canvas, which is a widely used thing. It's used in charting libraries and lots of and little games and lots of other good things. And so that you have to sort of combine these signals to try and see if we actually have fingerprinting. And there's the other heuristics are up there and in Steve's research. And this has been really successful, and some of the things that I think are really important about it, it works on minified and obfuscated code because you are just recording what got executed. The whole methodology already detects fingerprinting with very low false positives, and with the validation step, that basically goes to 0. That's our goal. We do not want to be blocking things that shouldn't be blocked. It's a peer-reviewed methodology. You all are academics and appreciate that step. It's privacy preserving. We're just using crawl data. We're not relying on user data or anything like that to generate this list. And as Steve described, we're already having an impact, seeing that little case study of TinyMCE choosing to remove a fingerprinter because they didn't want to be blocked. And this is amazing. Like these a relatively simple and straightforward thing to do, and it's really having an impact. And so I want to emphasize that before I get onto some of the challenges. And these are things that sort of inform my direction. And so the first one is that the ecosystem can evolve around these heuristics. And in particular, for simple heuristics that are just looking for a few calls of certain APIs, as those APIs become more widely adopted and become more widely used in general for valid use cases, where those simple heuristics are likely to generate more false positives. And so you get in this arms race of creating more sophisticated heuristics. Complex heuristics, like the canvas fingerprinting one that I described, become easy to evade. As people decide that they don't want to be good actors and just have themselves removed, they can add a save call that doesn't do anything but enables them to bypass a heuristic. In addition to that, there are other types of fingerprinting that we already know exist that we don't have heuristics for yet. In particular, there's browser attribute fingerprinting. So that's when you hit things like the user agent, the battery API if you're on Chrome, the screen size and depth and things like that. And that was like the original panopticlick paper from EFF was the first to sort of document that. So it's been known about for a while. Others have speculated that emoji fingerprinting could be a thing, although I haven't seen it in the wild yet. There's a form of fingerprinting called device class fingerprinting, which I'll talk about a bit more later. And then mobile sensor, using mobile sensors to identify devices, which Anupam Das has done an important paper on. And so one of the nice things about the heuristic methods is that, as I said, they have very low false positives. So we can feel very confident that we're getting a strong lower bound on the extent of fingerprinting. But that doesn't mean that we're capturing all of the fingerprinting. And so we don't necessarily know how big the problem is. Although I will say, our instinct is not that we're missing half of it or anything like that, but that there's a difference between false positives and false negatives. And then the last bit is that it only provides a limited window into new vectors. Now, Steve discovered like audio fingerprinting by looking at existing fingerprinting scripts that were doing, say, canvas fingerprinting, and was noticing this odd behavior, but that's very manual. And so these techniques don't provide like an automated window into new classes of fingerprinting. And so these are the sort of issues that I've been thinking about when I'm trying to think of like how can we keep the good work and keep our competitive advantage and being able to, want to keep stopping the behavior that we don't think is appropriate to expose users to. And so there's lots of stuff in the literature, and I wouldn't want to do a literature review in front of a whole room full of people who are masters of the literature review. But the few things that inform my work are the CLIXY group did some access with looking at browser data, and instead of looking at the JavaScript calls as a symptom of fingerprinting, looking at the generation of unique identifiers as the other end of the symptom of fingerprinting. So fingerprinting is turning JavaScript and browser attributes into a unique identifier, and so there's two pieces to look at there. There's also been lots of studies that are relevant to my work using supervised classifiers to identify trackers or blocking ads or anti-ad blocking and so on. And they use a variety of sources from static analysis, HTTP traffic, packet inspection, and so on. The fundamental challenge that we all face when we're doing web measurement is that there's no ground truth. And the best sources of ground truth really are the lists that we can currently generate from the heuristics or the privacy lists like EasyList and Easy Privacy that are all tailor-made for their own things and not necessarily what I'm looking for when I'm trying to can I reach beyond the lower bound that the heuristics have established? Like, how do I know how well I'm doing? And so I decided to take a semi-supervised approach to this. And so starting with crawl data, applying a minimal label set, and then seeing what else we label. So I'm going to get really into the weeds of this for a bit. And hopefully it'll spark new ideas and thoughts and critiques, and I look forward to having those conversations. So we're back with the same raw data that we use for the heuristics. And I am sort of focused somewhat religiously on that middle column of the APIs that were accessed. So I take this data and I transform it into vectors. And each of my observations, I assemble from the script domain, the script, the little bit at the end of the script path, and then the function name that was called, that a series of calls were gathered under. And so each observation is the relative frequency of calls to a set of JavaScript APIs over that little chunk or snippet of code. From there, we have all our observations, and we can we can pick a labeling strategy. And there are a bunch of labeling strategy. I've been mostly focused on labeling all the observations based on the scripts that were flagged by the heuristic methods. But we can also do keyword searches and just look for words like fingerprint or pixel or tracker in our observations. And then, or I'm also trying to think about new ways of labeling just labeling individual observations. So this is just semi-supervised learning. So now we just want to propagate those labels. And the way I take a very simple approach to this, and the simplicity of this has allowed me to really dig into what's happening at each step and try and tease it apart, rather than using a sort of out-the-box methodology. So the first thing I do is I compute the pairwise distances, reduce pairwise distance matrix from every observation to each of the labels. And then one thing that I found was that I needed to remove what I call leaky labels. And so the thing about a piece of JavaScript, let's say the whole Fingerprint2.js script, is there's a bit in there that's doing the canvas fingerprinting that I want to isolate, but then there's a whole bunch of just workhorse JavaScript in there that may be just regular JavaScript functions that ends up being shared across most of the code on most of the web. And so if you inadvertently label that because you've labeled the whole Fingerprint2.js script as bad, you just label your whole data set and that doesn't yield any information. So that label precision is a real problem. And so I take a very simple, just threshold-based approach to remove those leaky labels. And from there on out, it's a simple question of, for each of my observations, how many labels is it near? I then map observations back to scripts, and then a script gets a score based on how many, based on the aggregate of all that information. I have a library that's up at Mozilla DieScore. It's still in alpha. I have some known issues. You're welcome to collaborate, find more known issues, or currently unknown, soon to be known issues, and I welcome that feedback. And then at the end of the day, what you end up with is a list of scripts. And then we're back at the no ground truth problem. And so whilst I might have bypassed the need to create a label set up front and then go and work on supervised learning, I'm still now stuck with a list of, say, 5,000-6,000 scripts that I don't know what they are, and I have to figure out how well my labeling has gone. And so I've been working on some very simple tools to just build a website to help with script review. For people who've done measurement studies, script review is a big part. If anybody's interested in this, it's a bit of a tangent, but do reach out and I can open source this code on script review that I've been working on. And so I've had some initial successes. In particular, we are detecting instances of fingerprinting scripts that are clearly just other copies of, say, Fingerprint.js, but that had failed to meet the exact heuristic criteria, which could be for all sorts of reasons. The page was slow to load, who knows what other reason. In addition, we detected scripts that were just doing browser attribute fingerprinting. So this is scripts for which we didn't have a label on the way in, but we were able to identify them on the way out. And that's because scripts that do one kind of fingerprinting often do another kind of fingerprinting. And so those labels, that signal is able to spread out. We have also identified, and Steve and I were doing review on a results set, and we're seeing some scripts that look like fingerprinting but not quite like fingerprinting, and we realized that they were device class fingerprinting. So I'm going to go forward and back. Device class fingerprinting, if you're not as familiar with it, is a type of fingerprinting that was proposed in this paper, Picasso, where you're not trying to generate a unique identifier for a given browser. You're trying to accurately determine the class of device, the browser and hardware combination it is. And so this is often used in the kind of fraud, or this can be used in the kind of fraud and anti-fraud cases that Steve described earlier. And we were seeing these canvas images that we captured were actually from Facebook's implementation of this algorithm. Some of the other things that have been going well is that keyword labeling actually works surprisingly well. So looking for the word fingerprint gave us basically the same results as inputting the heuristic list. Now, obviously, this is not a sustainable. Just looking for the word fingerprint is not going to be a sustainable path for doing fingerprinting detection, but it does provide interesting opportunities to explore this data with a bit more granularity and be able to dig into what is otherwise a list of 2 to 4 million scripts. Where do you start? And then the last piece that I think is useful about this methodology so far is, again, let's say you start with 2 million scripts and you identify 5,000 as definitively being Canvas or what have you fingerprinting based on the heuristics, but then you don't have any information about what the other 1.99 million are. And the score that this methodology gives the script provides a sort and enables you to start looking in some kind of prioritized order at like what might be there. Of course, this is there are lots of challenges along the way too. And in particular, I'm getting a large number of false positives at the moment. And these are predominantly legitimate uses of the Canvas API. And so if something like the Canvas API is used on an order of magnitude more frequently than, say, the audio context API. And these uses fall into sort of two classes, I would say. They're firstly, things that we definitely shouldn't be flagging, like charting libraries or little games and things like that, which I have hope that we can eliminate them. And then the other class is things that are essentially doing the work of a Canvas fingerprint. So in particular, the WordPress emoji detector and the Modernizer's emoji support detection do the exact same set of steps that that Canvas fingerprinting does. The only difference is sort of what's written to the canvas. And so in the very specific domain, the very specific feature vector that I've set up, I don't think I'm ever going to be able to tease that apart, and we're going to need to bring in new sources of information. More challenges, again, at the moment I'm doing manual threshold selection, which is very common in semi-supervised learning, but is not a sustainable way to move forward with something that could be deployed widely. We're also seeing interesting variations between crawl strategies. So I mentioned before that typically Steve's crawls run over like the full Alexa top 1 million. We've also run crawls where we do a random walk in the top 10,000 and extract a million pages, but from the top 10,000 sites. And we found much better sort of signal to noise and much better results, like concentrating our efforts down there. And that might be because, as Steve said, there's more fingerprinting happening in more popular sites, or it might be because there's just a lot of noise in the long tail, and we haven't quite tangled apart all of that yet. And then lastly, similar to the critique of heuristics as being available, my current strategy for generating my features relies on the structure of a script. And that will also be subject to evasion and is inherently noisy. Like scripts can reorganize their code in a variety of different ways. And so there's a challenge there. And I've been thinking about things like information flow, or I was talking earlier about the taint thing that maybe is a new way to sort of pull out the right thread of scripts that we care about seeing. And so some of the things that I'm looking at the moment, which I would love to have a conversation, get feedback, any ideas, increasing my labeling precision, more automatic thresholding and metric experimentation, combining the output of this work with other features. And one of the things that's nice about only taking that basically one column of data is there's lots of other data that ends up being independent. And so you could really combine together different pieces of information and to generate a better answer. And that's something we're working on imminently. Negative labeling, so marking acceptable scripts, say charting libraries, but that presents its whole own other labeling challenge just in the opposite direction. Using results, and then a sort of separate thing that isn't necessarily so much about improving the methodology, but how can we take the results of this methodology and use them to help build heuristics for the for the browser fingerprinting techniques that we know are happening, but we don't yet have heuristics for. And then last but not least, anything to make the script review process or performance assessment less painful than the manual process that it currently is. And if all of that wasn't enough questions for you, there are also questions on the challenges associated with doing crawl as your data collection methodology, the challenges associated with evaluating intent, and then the challenges associated with deployment. So we have taken this list-based approach, and that has lots of pros, as Steve articulated earlier, but it also has some challenges associated with it, and Christoph started to get into some of the challenges of block lists. And along with deployment that's when you start thinking about, well, how do we measure how well we've done? How much of the web are we breaking? And so there's a whole other separate question about web breakage. So thank you for your time. I hope some of these questions have sparked interest, and I would love to talk to you about them.